Hello everyone. So today I was trying to explore LangChain's capability in doing a little more complex task than I had tried before. So LangChain, as you know, is a framework LangChain is a framework for developing applications powered by language models. I didn't want to be wrong about um, how I explain LangChain, hence I opened this. But yeah, so I was trying to do a little more complex task today using LangChain. And so what I tried was, so this is what I'm talking about. So there is a common CIDS, which is an ontology for, this is called Common Impact Data Standard. It is an ontology for representing social and environmental impact. So the main idea here is that you can, so using this figure, you can see figure 2 common impact data standard. Here you can see in a story there is organization involved, the impact model, the program, the service, what activity was done, input output. So basically think of it as a story of AI ethics. So I was uh, trying to go through few stories of artificial intelligence usage. So in systems where artificial intelligence has been used and there was some ethics related issues. um, so ontology like this helps you annotate that story on basis of this model, and then so that, for example, you have a story, so you can find, so in this AI ethics story, what was the program, what organization was involved, what impact model was there, what's the service that was involved, what activity was happening, what's the input and output to that activity, what's the outcome, and who were the stakeholders, impact, risk indicator, impact scale, depth, duration, like this. So this is basically, in short, common impact data standard gives you a way to annotate stories like the one I'm doing here. I'm using it in AI ethics stories. Here I was using LangChain. So I tried to explore LangChain's capability to annotate an AI ethics related story on basis of that common impact data standard ontology. What I'm presenting now is just one way of doing it. So here I'm again using OpenAI for it. So you have to mention your OpenAI API key here. So but I actually tried doing it in another way, which is not using a paid tool such as OpenAI, rather using open source tools such as Hugging Face. But the issue in using Hugging Face is that if you do it on a system which is low in RAM or GPU, it takes a bit of time. So but the advantage is free. But here OpenAI, if you use OpenAI, it does not run in your local, so you are using OpenAI API key and using OpenAI system. So it's light on your system, but it's paid. So I want to walk you through the code. So initially you need to install LangChain, OpenAI, ChromaDB, TikToken, and these are these are the imports that you have to do for the code further. So I'll start with here. So I started with a directory. Directory's name was Abhi, and it loaded all the txt files. There were two only. First txt file was about the common impact data standard itself. So it mentioned the common impact data standard txt looks like this. So it has definition of I just showed you the figure in which there are the common impact data standard mentions organization, program, service, these things. So how do we define an organization? How do we define a program? How do we define a service? How do we define an activity? And so on and so forth. How do we define each of these terms? Now, so I took two files like this. First was the common impact data standard definition itself, and second was the story, the AI ethics story that I was trying to annotate using this common impact data standard model. So those two files I took. So the other one that I was talking about is this, which is Microsoft teen pregnancy predictions. So this is a AI ethics related story where it says this is a data script from a website which says it was released in 2016. This unnecessary information has also got scraped, but I think, yeah, here it's the story starts. The technology platform for social intervention is a controversial algorithmic system used to predict teenage pregnancy in Argentina, Brazil, and Colombia. Developed in 2016 by Microsoft for the Ministry of Early Childhood in Salta Province, Argentina. The system draws on age, ethnicity, country of origin, disability, and socio-economic data of some 200,000 women and girls, including 12,000 between the ages of 10 and 19. So like this, you can see if you do it yourself manually, you know the organization involved is Microsoft, what activity is happening, so you got an idea. So who are the stakeholders, maybe the teenage girls, so these things. So basically if you read it yourself, you know what the program was, what the service was, what activity was happening, what's the input output, who is the stakeholder, what's the outcome. So that idea you can have manually. But let's say you have to do these annotations for 100 or 200,000 stories, AI ethics stories, then it gets really difficult because it takes a lot of time. So I was trying to automate that manual process using this code. So initially, for an example, I loaded two txt files. One was the ontology definition itself, and second was the Microsoft teen prediction story. And then you take the so after this, as I showed you in the last video, I have to do indexing on both the data, and then I'm using LLM capability to generate answers to my queries. So you start with recursive character text splitter. There are various splitters available. I think there is one character text splitter as well. So various splitters are available. So this is one of those recursive character text splitter. I think I should check it right now. How does it differ? So it says this text splitter is the recommended one for generic text. It is parameterized by a list of characters. It tries to split on them in order until the chunks are small enough. The default is this. This has the effect of trying to keep all paragraphs and then sentences and then words together as long as possible, as those would generically seem to be the strongest semantically related pieces of text. So if you want to read more on this, it gives you a whole definition of how and what this thing is done here. Also, I hope this has the character. Yeah, this has the character text splitter. So how it differs is this split based on characters by default /n and measure chunk length by number of characters. By single character, how the chunk size measured by number of characters. So basically, what I meant was there are multiple ways of doing this text splitting. So here I used recursive character text splitter with chunk size 1000 and chunk overlap 200. And once you get this object, you use it to split the documents. Documents is what you have what I have loaded here, which are the two text files. So it divided it into 8 parts here, as you can see. Text of 2 and text of 7 I just checked. So text of 2 is about a stakeholder is someone. So this definitely it is also shown here. It is coming from the ontology.txt, where it defines where I'm defining each of the terms of the ontology. So for example, here it is mentioning what is stakeholder, and text of 7 is about is coming from the story itself, the AI ethics story. wherein it's talking about Argentina. Senate rejected a bill to legalize something, and then it's coming, of course, from the Microsoft Teen Pregnancy Predictions text. DB is a folder in which it will process. It is using OpenAI embeddings. So to use OpenAI, it's paid, but what I'm using is a free new account. So it had initial $5 of free usage. So OpenAI embeddings is one of the options. You can have other embeddings, for example, from Hugging Face, but the issue is that you should have a powerful computer because it has to run locally, and yeah, it saves cost, but it's a little compute heavy. But OpenAI embeddings is paid and light to execute because it, of course, does not run on your local computer. So you did the embedding, and then Chroma is what I'm using for the database, database purpose for persisting it. So Chroma from documents, you give the texts, which I just split here, and then embedding equals embedding, which I'm using OpenAI embedding. Then persist directory is this directory. So right now the runtime was disconnected when I again loaded this page, but that's why it's not showing up. But here if I run the code again, a folder called db will be created. Then vector, so that's coming in a vector db object, vector db.persist to persist the indexes here, and then vector db equals none, so that you can load it again from the disk. And then again you have to give the directory you have persisted into, and then embedding function is again embedding, which is OpenAI embeddings. Retrieval QA.from chain type, you can specify which LLM you want to use. LLM is OpenAI again, it's paid. Chain type stuff, retriever is retriever, which is this, and then return source documents to return which of the documents it used to answer your question that you're going to ask. So here then I asked, the query is what is an organization. So in the ontology definition document that I just showed, it defines what an organization means according to common impact data standard. And then you use this QA chain, pass the query to get the response. Here the response was a full result, which says an organization is a group of people who work together to achieve a common goal. It gives the source document where it found the answer from, and the source was ontology.txt. And then I think it lists out multiple document, because see, in this one also it has the impact duration is the length of time that an organization's impact. So I think because the organization term is coming here, it read from here also to prepare the answer. Then the next question I asked, who are the stakeholders in the Microsoft Teen Pregnancy Prediction story? And it says the stakeholders in the Microsoft Teen Pregnancy Prediction story are the Ministry of Early Childhood in Salta Province, Microsoft, Conan Foundation, Argentina, Brazil, the government, and the people affected by the prediction algorithm. So I think the result is quite nice. Again, it gives the source it used to answer this. So the whole text it has given here. So it read this text from Microsoft Teen Predictions txt file, and then again this text from this file. Again, I asked the question, find the impact scale in the Microsoft Teen Pregnancy Prediction story. It says it is difficult to determine the impact scale of the Microsoft Teen Pregnancy Prediction story without more information, and it gives the source document that it referred before answering this. This is just a cleaned version of the report. So LLM response is an object which has query result source documents. I just accessed the result part. Then again, I asked another question which has find the following in the Microsoft Teen Pregnancy Prediction story. I asked everything that I could from the ontology. So it asks organization, impact model, program, service, everything. And here it gives a very nice result, which has the Microsoft teen pregnancy prediction story, includes an organization, which is Microsoft, a program, Microsoft teen pregnancy prediction program, a service, Microsoft's predictive analysis service, activities collecting and analyzing data, inputs, data and resources, outputs, predictions and insights, outcomes, reduction in teen pregnancy rates, stakeholders, teen parents and healthcare providers. So I think quite nice. So I was pretty much impressed by the results it gave here. And yeah, so that's all I wanted to cover here. So how I utilized LangChain today was to give it a little more complex set of complex use case, and I fed it with the ontology definition, and then asked it to basically annotate an AI ethics story on based on that ontology, and the results were quite impressive. So this is it for today's video. Yeah, so the main conclusion from this was the result is quite impressive. So for example, if I had to, so further cleaning can be done. So from the result here, where I have got each of these terms, organization, service, activities, these things, I can extract each of in terms of a key value pair in the JSON file, and then maybe go over it for all the 100-200 stories and extract as a database. But the only problem is it is paid, and the free versions like Hugging Face gives you models to do this. Basically LLM models is for one thing where I used OpenAI, and then in embeddings I used OpenAI embeddings. So I think these two parts, for these two parts you need either OpenAI, paid tools like OpenAI, or some open source tools. So OpenAI is paid and light to execute. Open source models are run local, so heavy to execute and free. So that's it for today. Quite impressive results. Thank you. I will put this notebook in the link in the description if you want to check it out. Thank you.